I'm Britney Blodget. I am a senior product manager at Docker. I work on the supply chain security team. I know I'm the last talk before lunch, so I'm going to try to race against everyone's hunger pains and hopefully not bore you too much. So we've all seen how containers have transformed how we build and deploy software. And today I'm going to share how OpenSSF, how we at Docker are applying OpenSSF standards to fight against some practical challenges from build integrity to vulnerability management. So let's start with where we are today. The container ecosystem continues to thrive. On Docker Hub alone, we see over 25 million image pulls a month. And developers are pulling anywhere from simple web application frameworks or to complex AI models and inference engines. And actually, that's where we're seeing the most exciting growth is with AI and machine learning workloads, anywhere from containerized PyTorch and TensorFlow to LLMs, which are among the fastest growing categories that we have on Docker Hub. But this growth also represents, even though it's incredible innovation, it also brings in new considerations around security and supply chain management. So we all know that the threat landscape continues to grow. Cybersecurity Ventures forecast that the global cost of software supply chain attacks will reach nearly $138 billion by 2031, which is up from $60 billion in 2025. And then cybercrime costs are expected to rise from $9.2 trillion in 2024 to $13.8 trillion by 2028. And we've seen some notable supply chain incidents over the years, from compromised packages and language libraries to modified container images, and recently concerns around AI model integrity and the training data provenance. But the interesting challenge is that the container ecosystem's greatest strength, which is our interconnectedness and reusability, also creates a complex security landscape to manage. Attackers know that containers are force multipliers, and so when you compromise one base image, the potential to affect thousands of downstream applications. And we saw this happen most recently in 2024 with the attempted XC utils project takeover, which demonstrates how widely used components can become entry points for malicious code. And then as we add AI workloads to the mix, new protocols like MCP, we're just expanding into territories with their own unique consequences and considerations. So the question really becomes, how do we maintain the innovation and ease of use that the container ecosystem brings with building better security practices? So this is where the work happening in OpenSSF really becomes valuable to the community. We have SALSA, which gives us a framework for proving that software wasn't tampered with during the build process. And when you implement this properly, it makes supply chain attacks harder to execute and much easier to detect. Then we have SBOM standards, which gives us transparency into what's actually in our containers. So instead of treating images like they're some black box, you can know exactly what components are in the image and track the vulnerabilities as they're discovered. We have VEX statements, which helps us cut through that noise because not every CVE is exploitable in every context. So VEX gives us a standard way to document that reality. And then last but not least, we have cryptographically signed in toto attestations, which provide proof that ties all of this together. It's verifiable evidence of who built what, when, and how. And so these standards give teams a practical tool set to make informed decisions about the software that they're consuming and shipping. And we are already seeing how these standards are increasingly adopted with the growth of SBOMs that are generated year over year in the chart on the screen. So now I'm gonna show you how at Docker we're actually implementing these OpenSSF standards in practice. And I'm gonna use Docker hardened images as an example. And bear with me, because I am navigationally challenged when I have to go through here, because I wanna pull up my terminal. All right, so what we have here is I'm using the Scout CLI, and I've just decided I'm zeroing in on our hardened Python image, and specifically our FIPS variant, which, as you know, being able to have the attestations and verify them is very important, or else we wouldn't meet the FIPS standard. So I just listed out the attestations that come with this image, and we can just get a high-level overview and the package count. If you go down, you can see all of the attestations that we have. So we have the Cyclone SBOM. Further down, we also have the SPDX version of the SBOM. We have our vulnerability attestations, our VEX attestation, a lot of other Scout attestations around provenance. Specifically, I'm trying to get down to our SALSA, because that's what I always feel is one of the most important ones. So yes, we have our SALSA provenance here, and then our SALSA verification summary, and then the XPDX SBOM. And so then, we listed out the attestations, you see what we have, but you still are gonna wanna verify them. There we go. So now here, what I've done is I've zeroed in on one particular attestation, our test attestation, and I'm verifying it for our Python FIPS variant. And so you can see we're using SigStore to sign our images, and we're utilizing the cosign client to verify. And so you can see the signature payload. But more than that, because we're looking at our test attestation, you can look and see the tests that we actually are running. As I said, we're looking at the FIPS variant of our image, and so there's a very particular FIPS test that we need to run. And so you can see what those are and if they passed. So like for instance, right here, we're seeing that we're running one FIPS test, and you can see all that happens in that test, and then you can see that we pass that test, and then there's more FIPS tests that we run. And so all of these attestations that I just showed you are distributed as OCI 1.1 refers, which means that any registry that supports that spec can automatically discover and serve this metadata alongside the image. Sorry, I'm trying to pull this back up so we can see it more clearly. And then navigate back to my screen. There we go. And so this is what OpenSSF means by transparency, verifiability, and trust in the software supply chain. This metadata gives developers, security teams, and auditors high confidence in the image's security posture without needing to rebuild or reverse engineer it. So one thing we learned is that security isn't just about building things correctly, and I know I've spent the last 10 minutes basically talking about building things correctly, but it's also about maintaining security over time as conditions change. 95% of the time, when vulnerable components are consumed, a fixed version already exists. So despite the availability of patched versions, consumers continue to make poor decisions over selecting their dependencies. And this behavior underscores the need for stronger security awareness and enforcement mechanisms. And this is where policy comes into play. Policies are a natural extension of secure builds, and it's how we verify that those builds remain trustworthy, because images that are secure today may not remain secure tomorrow. This is something we're also prioritizing at Docker with Docker Scout, but the broader idea is that policy needs to be flexible, contextual, and enforceable across the SDLC. With our policy engine, which I don't have time to dig into it right now, there's a screenshot of it, but we're using Open Policy Agent, which uses Rego. It's flexible logic-based language. I call it kind of policy for dummies, because even I could probably write a policy with Rego. And with the policy enforcement, we can block images that weren't signed by a trusted builder. We can require the passing of test attestations before deployment, and we can prevent CVEs in production unless there is a VEX existing. And then we can also apply different rules, different policies to different environments. So you can have less stringent rules for your dev environment and then really strict rules in production. And then these policies, they should be portable and standardized and shareable to, so whether you're on Docker Hub or another platform, you can enforce the same security expectations. And so these security standards we implement with Docker's tools are designed to support the entire container ecosystem. They're built on open formats like Salsa and Toto attestations and SigStore, and designed to interoperate with any compatible tooling. And so this enables us at Docker to bring these standards to life through practical and scalable implementation of OpenSSF supply chain vision with Docker hardened images, which provide a secure foundation for minimal and audible images that are Salsa compliant. And then Docker Scout, which enables us to continuously validate, ensuring the images running today still meet the policies for tomorrow. So if there's one takeaway from my past few years at Docker, it's that the container security is most effective when it is a shared responsibility. And so the more teams that adopt secure defaults and policy enforcement, the more resilient our entire community can become. And so hopefully y'all learned practical ways to implement this in your SDLC. Thank you.